Yes. So I am looking. We should be live here in 2 seconds. Welcome to another episode of Coffee and Compressed Air. Today, we want to hop right into it because it's AI. AI is everywhere. But I am very curious on this one because immediately I feel like if I were to tell somebody, like one of my relatives, oh yeah, we're doing a podcast on AI in compressed air, they immediately think Chat GPT and like, what can Chat GPT do? I feel like that's the default. Whenever you say AI, that's where the normal person's brain goes to. So I'm excited to hear what you have to say on what type of AI and how it can be used in compressed air.
Thank you. Hello, everyone. And it's not me today, Elvira. It's an avatar that we created using AI technology. No. So welcome everyone to our wonderful podcast. It's not even a podcast. It's like a video
Yeah.
broadcast. We always share some information about it. I want to talk about AI. Maybe we can have next time, I know, 4 hours to talk about the application of AI in compressed air. But today I want to question the status quo as usual. Maybe jeopardize some technology that exists on the market, and just let's say give some food for thought and show you how I use AI for compressed air systems. Again, not how I use AI in my life in order to create the reports and or in order to create some blog posts or videos and content.
Mhm.
It's not how we use it for compressed air, but what is actually essential for using the AI. I have a few slides to share. Let me just go ahead and start sharing my screen. And while I'm sharing my screen, I want to ask our listeners if you have any experience with how AI can be used in compressed air systems. So, do you see my screen now?
Let's see. Yes.
Perfect.
Are we
And
looking at the right screen?
um,
It's a
I mean,
is
it
it
has to be video.
oh, okay. Okay.
Yes.
Yes.
I mean, what you thought?
I don't know what I'm looking at.
Okay, so this is the video that is not playing. Ah, no, it is playing. Let me go back. So this is an app. This is my dog Douglas, and the app recognize what type of mushroom it is. So you need to know two things about me. I love to collect mushrooms, but I do it in Russia with my grandma because she's actually my app that she knows everything. So this is why I'm still alive and enjoy this. Go into the forest to collect it. I don't do it in Italy because my grandma is far. And I love my dog Douglas. He's also a head of our HR department in Direktin. So this is an app, and it's actually old thing. So I need to check again the app. And this app recognizes the mushroom if it is a poisonous or not. I just decided to test it on my dog, and as you can see, Douglas happened to be a liberty cap mushroom. That is apparently psychedelic mushroom. So what is wonderful about this app that it uses amazing, extraordinary AI algorithms for identification. So you can be really sure that you're not gonna die when you eat it, and you also can be sure that you can identify your dog, what type of mushroom he is. So while we still in this, I mean, it's a funny intro, but it's not actually funny because we we decided to make it like more relaxed. But I um, I have a very important thing is to say that AI and machine learning. When we talk about the machine learning, and I'm not an expert on the machine learning, so I have an expert who can consult me also on that and how to use it. I'm very curious about this, and I'm curious about the algorithms that can help us for compressed air systems and in general for industrial energy efficiency. I'm also an engineer who knows the physics behind that. And I think this is extremely important to remember that AI, when we have a machine learning, there are two types: a supervised machine learning and unsupervised machine learning. So supervised machine learning is basically what is mostly used in the industrial systems for industrial application. In general, any science-based stuff, a lot of things like use supervised machine learning. It's where we have a very simple words to say. We have we're developing the algorithm is learning the behavior, and then we correct also this behavior. So as an observer, so we have the supervision for this for those algorithms. For those kind of algorithms, just show you now in another example. So we need to collect a lot of data in order just to understand, just to give this data, that the algorithms will learn on this data and will perform the output. It works like as a black box, right? So we input, we say, those types of, if you see something that is long, white, has maybe a little bit brown, and has like a little bit of, I don't know, like curly things around, and has also like the round head, this is a liberty cap mushroom. But when you put the dog photo, and you saw it, you see it now a lot of also on the online, like there's also dog croissant stuff, you know, like that you have like the dog and the dog croissant, find the dog. So exactly the same thing. We are training it on the algorithms will train on the mushrooms, not on the dog. But how much data about the compressed air systems we actually need to feed to our AI algorithms in order it can understand what is actually happening. And the crazy thing is that compressed air systems are so complex, they're so different. There are no standards behind this. There are standards, but let's say there are a few standards that are quantifying, that there are calculations behind the physical standards. There are complex thermodynamical laws behind that. The data that you find nowadays in the open source, if you ask also ChatGPT, let's go back to LLM models and ask about the various calculation of compressed air systems, doesn't make sense. So it will tell you the non-compressed pressure drop calculation for non-compressible fluid. Then you start again the discussion. Then it will, you are right. Maybe let's change it. Again, another meme from internet that I see all the time is like in the hospital that the guy's like asking like, is this disease like dangerous? Like, should I do surgery? No. And then the guy is dying in the hospital and like ChatGPT, wait a second, you are right. This disease was really dangerous. So the same thing is here. You need to have an enormous amount of data and you need to train the data correctly. My question is, do we really have enough of not the data, but interpretation of the data that is correct? The analysis of the compressed air system are done not going out of the compressor room itself. It's wonderful, you collect the data about the compressor room, but what is happening when you go in outside? You don't understand what is happening there. Example from my audit. One day I came to the facility, and then they told me that I was a third auditor for the facility, and it was a huge spike in the consumption, 1,000 liters per minute, really big spike of the consumption that cost about 100,000 euros per year, and it was just 150,000 per year, and it was just 2 hours of operation every morning. So something was wrong with the system. Some ghost came and opened something. No, it was already like the shift is running, something is happening. So what they did, they installed the monitoring system and they gave it to the company that does the AI algorithms. And now I'm going to be really negative against the companies that claim the AI algorithms. And you need really to think for what you use those AI algorithms. And then they said, yes, you have this peak, it causes a pressure drop and problem in another process. So, and the process is critical and blah, blah, blah. So what you have to do, you need to get a bigger compressor, bigger receiver, bigger pipe, so you can compensate the peak. Makes sense, right? You need to compensate the peak, so not to have the problem. And this is what I don't think you really need AI algorithms for that, but okay. So this is like
Mhm.
this is something that the common sense and auditor usually would say that, but it was based on the AI thing. And sometimes I feel that AI is really so much overused in our industry. It's insane
Mhm.
because I've never seen actually AI that has been really used for something, because it has its limit when you don't understand the physics of the system. Then you go to the AI, and I go now just in a second about it.
Mhm.
What happened there, and probably I told the story already a few times, is that we went on the demand side. We spoke with operators that work in that hours from 4 to 5 a.m. And then there was a really nice operator guy who showed everything, Giovanni. It was in Italy. And he said, like, and I said, Giovanni, how is the life? How is like, yeah, it's very foggy region here. It's very like, and the facility is like half outside, half inside. It's like very heavy, like aluminium recycling plant. And then he's like, every morning before I take my coffee, I need to go to open the compressor, the pipe. I have the pipe because I have so much fog. I need to remove the fog using compressed air. So he removes it, he leaves it, this open huge pipe, and then he goes to get the coffee. And it's about 1 hour and a half. It is running, so then Giovanni can work. I can understand Giovanni. I also wouldn't like to work in the fog, right? It's dangerous, it's unpleasant, and so on. But this was the peak that I really want to see an AI algorithm that can actually tell about.
Yeah.
So, yes, maybe it can tell about the anomaly, of course. But the
Mhm.
problem is that it will take how much anomalies you have in compressed air systems.
Yeah.
Compressed air system in general, it's an anomaly. It's in general, it's I don't know. They are. It's like a piece of art. It just grown. There
Mhm.
are. We speak with engineers. We speak with different auditors, with the companies that evaluate, and it's insane. Like that sometimes there is not even like a common standard of understanding how the audit was done, how the calculations were done,
Mhm.
and again, it's an engineering system where we have a loss of thermodynamics. We can understand a lot of things in compressed air system, and we can understand and calculate a lot of things. And the problem is because it's so hard to, it is not standardized like electrics, like electronics. It's so hard to collect. You need to train, I don't know how much data you need to have in order to train it on all systems. And what usually we see, and very often what we see, is that AI algorithms that reduce compressed air consumption. Okay, fine, wonderful. Let's call them AI, although it can be just like a simple statistical algorithm there.
Mhm.
And it starts to reduce the. We know that reducing pressure level will reduce energy consumption. Without looking at the demand side, what it usually does, it reduces. Also, sometimes there are also algorithms and systems that you work on the demand side, on the machine itself. It starts to reduce the pressure level, and it learns. So it checks when something wrong is happening. Either the operator comes screaming from the demand side into
Mhm.
compressor, there is not enough pressure. The machine starts like to the alarm goes on. The machine starts to switch off, and it's not a secret. There are many systems that exist nowadays on the market that actually stop simply the production by reducing pressure level until something goes wrong. It is not an AI algorithm. It is not a smart thing. It's not a good analysis. It's not a good thing to do and to claim that this system have to be used that way. And I think we should have more and more discussions about the AI using compressed air systems. I want to show you how I use it my um, for my tasks. And here, so there are a few things let me do just this slide first. So here I explain you how usually it works, the algorithms. So here I have the training model on this side. So this is the training value and patterns. So people that you, if you work with machine learning, you know it very well. So here you have the targeted value for me is was a pattern of the velocity in the cylinder drive. So I have here the measurement, I have the simulation, and then basically based on the various cycles of cylinder, so it goes like up and down, so basically the velocity curves, I have those patterns. So once I have the step, it goes up, once it goes down. And once I trained it, basically on the many cycles, I could train the how the velocity curve should look like. And this is the learned position of, then I measured the pressure, and based on the pressure curve, I learned how the velocity, I teach my algorithm how the velocity should look like.
Mhm.
Here is a very important moment. So if anyone is listening to us, just focus. Exhale, inhale, exhale, and focus. I'm not teaching the algorithm how the pressure curve should look like based on the velocity. I'm teaching it here for one reason, but I'm not teaching it just for the sake of, because I don't know how the velocity curve should look like, or position curve should look like. Those curves, I can simulate them based on the lumped parameters, or concentrated parameters to call them. I can simulate it based on physical equations. I don't need machine learning to understand how how the curve of the position, of the velocity, of the pressure would look like. It doesn't matter. I don't need this. And what I usually find in the claims of the algorithms, that it gives you those positions. You don't need it. It's a physics. It's really mechanics, thermodynamics, and you can obtain all curves, all parameters can be calculated without any AI algorithms. Okay? But what I find here is interesting is that I can teach. So in order to get, for example, measurement for my cylinder, I need to have the sensor for the position and sensor for pressure. Okay, so I'm not talking here about the flow. It's quite a small cylinder. So I need, for some certain application, I need to know what is the position when the cylinder reaches the position where are there certain pressure levels. I need to install two pressure sensors for this cylinder on the both side, and I also need to have the position sensor and stroke sensor. And I can teach on many curves on how it can look like. So I can eliminate one sensor and, for example, install just one position sensor and one pressure sensor, or maybe two pressure sensors, non-position sensors. I can make my cheaper, so I can use then these curves, for example, for the future predictive maintenance algorithms. This is what we're working on right now, and this is for what this can be used. So, but I cannot, I need to have a lot of experimental data. I need to have a lot of simulation data for that, and it's going to be done only for one type of the cylinder. So I need to train them for the next step of the cylinder, next type of cylinder, and this is only one cylinder. So
Yeah.
imagine when we talk about the whole compressed air system with the compressor room and with everything. And if you don't know the demand side, if you don't know what is happening there, here I have a clear goal. I want to make my physical system cheaper. I want to reduce one sensor there. I want to have the installation quicker. But I'm not trying to predict the curves that I calculate myself using the physics. If I go in the entire system, so here, for example, this is the model that goes like this, prediction of missing data, like autoencoder. So if you have some data, you actually in the input, you can understand what is the data in the output. And this is very interesting application for machine learning, because I have here, for example, I have here a big system, and as you know, it's very complex. It's very complex because the maintenance is quite bad. You don't know what is happening there. Something had changed. Again, Giovanni decided to start to drink coffee, and like something, something else like that happened, and it affected the pattern here. So I cannot calculate every single knot, right? So the what I said before, the lumped parameter simulation or concentrated parameters were calculate one knot at a time. So here I calculate pressure flow, and so on. So here, for example, I can use machine learning algorithms. I can use here AI to identify the nodes that are missing. So it can save me time, the calculation time, and it can also predict better and understand what are there also the anomalies there. But again, it has to be in order to, I think, to arrive to meet the demand with the supply and really use machine learning for this kind of applications where we really want to understand what is happening on the demand side and we want to reduce the compressed air consumption. We need to first understand, do we actually need artificial intelligence and machine learning, because it's also a lot of energy. We need to remember to use it, to train it, right? Then we become controversial, energy efficiency versus consuming less to consume more. So it's also like a bit weird. But we need to be really conscious on for what we use it. So we, again, AI machine learning for engineering system should be used where the physical limit is reached. Physical limit is reached, I mean, where our knowledge, physics, it cannot go further ahead. When there are some anomalies, something like is crazy happening, what is extremely hard to imagine actually in industrial systems. So I can imagine, for example, for climate models, that is there are so many variables, so many parameters, but I hardly can imagine it in the compressed air systems. Then we need, if we really need to use, we need to analyze a lot of data, and by a lot I mean, I don't know, like 50% at least of 60% of all the existing system like in the world to analyze it. Or what I prefer to use it for now is that I understand my system physically, I can describe it physically, but I want to make it faster, quicker, that is the same, or cheaper. Cheaper in sense of the installation, in sense of the sensors, in sense of the maintenance. So I can write different tools around it that can help me to optimize the model. So, but and this is, I think, it's extremely important to remember. Sometimes people really run after AI, okay, but sometimes it's not good.
Yeah.
Before you decide to install the system that is trained on AI algorithms, ask how many facilities it's been trained on. Because train AI on the facility, it's a big thing also. So one thing is you do collect the data and you train it just on the data. Another thing is that you really install it and you train it on. So it is, I think it's a very, it's not an easy, not an easy task. And I think it's actually very dangerous to claim it, and it can be also counterproductive very often to claim it. So I usually have a lot of things to say about it. I think it's amazing when you use it to optimize things, make your work faster, quicker. As I showed, I use it for optimization, removing some sensors, making algorithms quicker, learning some interesting curves for some predictive maintenance, for more sophisticated stuff. But when we need to understand both supply, demand, and the distribution, first we need to understand how the system works, describe it with the equations that exist. And when we really don't have any more equations to describe, then we can maybe go and analyze it. But it's amazing for reports. I write in emails too.
Perfect.
Yeah.
I think you gave everybody a lot to think about, and maybe question a little bit, or at least do some research into it. If AI has been used a lot for marketing too, like you said, it's a buzzword. it's marketing, everybody's curious about it. A lot of people don't really know about it in order to ask any questions. You know what I mean? Like, I personally wouldn't know what kind of questions to even ask if a tool says AI. Like, I know the basics on, like, the LLM and some of that, but as far as this marketing thing, like, what do you think is a good question to
I mean,
ask? So you facility one.
if you install the system, if you install the system that has used AI, I would ask on how much data you trained your algorithms.
Okay.
How many use cases you put inside there. So imagine it's a compressor control or something else.
Mhm.
So first of all, what is the how? This is the first thing. How many use case are there? And this is really the first question. If it is like 10, if it is 50, if it is 100, if it's 200, or even 1,000, it's not enough.
Yeah.
It's not enough to have this to have the data trained. So just to start this on what kind of a use cases was it like trained? Was it trained just separately supply and demand? Was demand trained at all? Was it like measured there? Was it the simulation, only the simulation, or you did also measurement? Did you do the validation? Validation means that I simulated something, I measured it, and then I validated with the measurements. Very
Mhm.
often, I don't know why, but very often I see claims in some softwares, only simulation softwares that I saw, validation against the calculations. And like, it doesn't make sense. It has to be 100% the,
Mhm.
the match.
Yeah.
But
Right.
also, what is the deviation between the 100%? What is the deviation between the measurement and the validation?
Mhm.
I'm not also an AI expert, but I'm an engineer who would use those algorithms, right? So I'm an
Mhm.
engineer. So before, how I use it, it makes me faster. It makes me so fast, but whenever I always have to check if it makes sense or
Mhm.
not, right? So,
Yes.
and if, for example, the company doesn't work at all with the demand side and they work only with the compressor room, and yes, maybe the algorithms work only for the compressor room, but you will never then understand how you can reduce your demand side because it is a demand driven systems. So
Yes.
it's also to ask what is the is it like was it on which type of a data it was it trained. So this is extremely important to understand what was put there before. So was it measurement? Was it only some catalogs and data from the thing? And I think the
Mhm.
question is why AI? Why not physical equations?
Mhm.
So why you decided to go? Where is the this limit where you stopped from the physical equations of the compressibility and understanding how the system interacts, and
Mhm.
decided to go into AI? Because this is very very dangerous. If there is only AI, so it's basically as I told you, you show the pressure curve, and then it learns that the velocity has to be that way. You have here a little bit of oscillation, here you have a bit of oscillation in the velocity. This is how you train it. But you actually can achieve exactly the same thing simply with equations. You don't need to go into the AI. You don't need to train your
Mhm.
models for there. And this is very, very, very important thing. So otherwise you
Mhm.
get your dog to be a mushroom. So I don't know if you want this. And for sure algorithms are evolving, and for sure it has to be used. And again, I use it really a lot. For me it's a saving tool. It makes me quicker, but I need to know what to expect at the end
Mhm.
outcome. I already know, I suspect what is going to be outcome based on my experience, based on my knowledge. So, and a lot of time it just gives us nonsense,
Mhm.
and then tell this is a nonsense, and I said, yes, I agree, it is a nonsense. So let's rethink it again.
Yes.
Yeah.
Yes. Interesting. Awesome. Well, thank you. That's all the questions I have. That's a lot to take in and think about, but I think everybody's had a similar experience as uh, Douglas being a mushroom, using AI, the people that have, played with it. And of course, it's thank you for catching that. That's a good catch. Way to mention that. But again, you only know that from your own experience. So, and it's very obvious when people are using it and not matching up their experience as well. Because
Well,
you,
AI can be used in a very, very good way. That I can say is that raising money from investors. So if you put the word AI, I know it from my own experience. And when when we tried to raise money for Direktin at the beginning, and we went to the consultant on that, they just told us directly, okay, this is how it works for the evaluation. If you put the word AI, you multiply it by 10. And I'm like, we don't use directly AI because you don't need to use AI. That's like I said, like we can put some AI agent to help, like some chat bots, like some reporting, automatic reporting, and those kind of things. I said, but we're not going to use it for the simulation program. Like we're not at that stage to use it
Mhm.
yet. So we don't have enough data, we don't have enough algorithms to train in order that, and now it works. It works good enough with the 5% difference from the measurement, what is extremely good for compressed air systems.
Mhm.
So, they were asking me, no, but like for investors, it's important. It's like time, like 10 times more evaluation for the company. You can make more money
Right.
on that. But I said, but if we put AI, it is more. It's because the algorithms, they're really consuming a lot of energy. It will not make sense then at the end. If we're reducing the energy, well, we also need to be conscious about it. And yeah, I mean, if you want to raise money for your company, definitely put AI. No, I'm not joking now.
No, that's why it's so funny. But that's again because people see it as the buzzword, and everybody's so curious about it.
Yeah,
So, I mean, attention goes like wherever the money goes, attention goes. So, like, if
yeah,
the attention's
exactly.
on AI, that's where all the money's gonna go. So whether or not it's correct, that's another story.
It's
Like you
this
said
is the
earlier.
world we're living, right? So what we can do with that? But in general, for if you are an energy manager and you're installing the systems and you are doing the ask those questions on
Mhm.
why the AI is used there and for what exactly. If it's just like to speed up the algorithm, the process, I think it's a very good point, definitely. If it is like AI algorithms decide on where to reduce the pressure in your facility, I would question like how, on what exactly. I mean, maybe there are algorithms now that are amazing, that have been trained on million of data that we don't know. But when just it's a good thing to ask. And if there is anyone that we know who works on the AI in compressed air system, we'd be really happy to invite for the next talk and to understand more and discover how it is used in the industry. So I
Interesting.
think that's all from today.
Yeah, we definitely went over, but this is a very
As
curious.
usual, yeah. Our coffee chat has become longer than usual.
I feel like that's how it normally goes when you're in an office anyway. The break times start to get longer and longer, like with your coworkers slowly. So maybe that's what's happening. But all right, thank you everybody. We'll see you next week. Thanks for joining us.
Thank you. Bye.